are two complex numbers satisfying the equation mod of z1 plus z2 divided by z1 minus z2 equal to 1, then the ratio of z1 and z2 is a number which is positive real, negative real, 0 or purely imaginary. This we need to find, right? So it is given to us that the mod of z1 plus z2 divided by z1 minus z2 is equal to 1. Whenever such mod is equal to 1, we can write this number as z1 plus z2 divided by z1 minus z2 equal to e the power iota alpha, right? And where alpha is real, and this is equal to further cos of alpha plus iota sine of alpha. This is your IIT formula, that is e the power iota alpha is equal to cos of alpha plus iota sine of alpha. Right? Okay. Let me write this as divided by 1. Now I need to apply the combinator and dividend rule over here. So that is adding the numerator and denominator divided by subtracting the denominator from the numerator. Similarly, on the right hand side, adding the numerator and the denominator and then subtracting the denominator from the numerator. So I can write this as negative 1 plus cos of alpha plus iota sine of alpha, that is one and the same thing. Okay, so z2 and negative z2 cancelled out, z1 and negative z1 cancelled out. We get twice of z1 divided by twice of z2. So this 2 and 2 is also gone. So the ratio is z1 over z2 is equal to 1 plus cos of alpha plus iota sine of alpha divided by negative 1 plus cos of alpha plus iota sine of alpha. As we know that 1 plus cos of 2 theta is equal to 2 cos square theta, right? So for 1 plus cos alpha, we should write 2 cos square alpha divided by 2. Is it fine? Just take your theta to be alpha by 2. Fine? Alright. Plus, now sine of 2 theta is 2 sine of theta cos of theta, right? So replacing theta with alpha by 2, what we get? Sine of alpha, that is equal to 2 sine alpha by 2 cos alpha by 2. So this is 2 iota sine of alpha by 2 into cos of alpha by 2 divided by, and now for the denominator, we know that 1 minus cos of 2 theta is equal to 2 sine square theta. Now replacing theta with alpha by 2, we get 1 minus cos alpha. So that will be equal to 2 sine square alpha by 2, right? But I'm having here cos alpha minus 1. So for that, just take negative sign outside and shift this negative sign over here. So I get minus 2 sine square alpha by 2, right? Plus, similarly, the same way, iota sine alpha can be written as, yes, sine alpha is 2 sine alpha by 2 into cos of alpha by 2. And now taking common 2 cos alpha by 2 from the numerator and 2 iota sine alpha by 2 from the denominator. So taking 2 cos alpha by 2 from the numerator common. So this is cos of alpha by 2 plus iota sine of alpha by 2. And taking 2 iota sine alpha by 2 common from the denominator. So because I have also taken iota, so I must divide sine alpha by 2 by iota, because iota is also taken common. So this is plus cos of alpha by 2, right? Now this minus 1 can be written as iota square, right? Iota square is negative 1. So I'm writing this negative sign as to be iota square, and this one iota will be cancelled out with the iota present in the denominator, and these two terms are now same. So cancelling these two terms, we get z1 over z2 equal to, yes, 2 and 2 also cancelled out. So this is okay. Let me write this iota, just rationalize or multiply and divide by iota. You get this to be as iota cos alpha by 2 divided by sin alpha by 2 is cot of alpha by 2, and iota square becomes negative 1. So writing here negative sign. Right. Now z1 over z2 comes out to be as negative iota cot of alpha by 2. Can this be 0? Can the right hand side be 0? Yes. Now when the cot alpha by 2 is 0, it is purely imaginary. This is very well known that right hand side is purely imaginary. The option is D. But this right hand side can also be 0 for what value of alpha? If I take alpha to be k pi, where this k belongs to the integers, that is the odd integers, right? Because for the even integers it will be undefined. So for the odd integers, that is for 2n plus 1, where n belongs to the integers, right? So for this general solution, this right hand side is 0, that is cot of k pi by 2 is 0 for the odd values of k, right? So this becomes also 0, the right hand side for these values. So let me write this again. That is z1 over z2 is equal to negative iota cot of alpha by 2, which is purely imaginary, but for alpha to be equal to k pi, where this k is 2n plus 1 for n belonging to the integers, right? That is only the multiples of pi by 2, right? So for this solution, this z1 over z2 is 0, right? So option C is also correct and option D is also correct. Thank you.